Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In this session, I want to go over radical equations quickly. Should be an easy topic, really. So what we are going to do now is to look at some equations and try to find the value of x that satisfies these equations. Be careful, however. It's like the logarithmic equations. The problem is that once you solve the problem, you have to check your answers because some of the answers will be or may be erroneous. Why? Think about it. If I ask you to solve this problem, you pretty much everybody know, but even if you are not 100% sure, think about it and you should find it. The problem is that we have a square root on the left-hand side, right? So if we both square, why do we square? Remember we mentioned that usually when we try to solve for a variable in algebra, it's common sense. You apply the opposite. So for example, if I raise something up, if I want to bring it to me, I will bring it down. I do the opposite step. If I add something to x, I would subtract it. If I subtract, I would add. If I multiply, I divide. If I take a square root, I have to square because these are called inverse functions. They cancel each other. Logarithm and exponent cancel each other. Later, you will see trig functions and inverse trig functions. They cancel each other. So the reason we want thing that cancels what other functions did is to solve for what's inside that function. But be careful. The problem didn't have a square on the right-hand side. It was just linear. And the left-hand side, to simplify it, you squared both sides. So now instead of x having maybe one answer, you introduced a new one. So you have to check if that other answer was already there or did you introduce it erroneously by squaring. We are squaring to simplify, not to solve. We are squaring to simplify the problem and make it easy to solve. Okay, and then so once we find out the answer, we have to check. We say, oh, the problem I had to square, meaning I might have changed the domain of x or something. So let me check and see if the x that I found were already satisfying the equation or not. That's all. So just a quick check, and it doesn't take 5 seconds. So now let's solve the first one, which should be pretty straightforward, right? We said we are going to square both sides. So let's square the left-hand side and square the right-hand side. The square cancels the root. So I get 3x plus 7 equals x squared minus twice x plus 1. And now it became an easy quadratic equation. I can, again, if you wish, subtract 3x from both sides and subtract 7 from both sides. So I will get x squared minus 5x minus 6 equals 0. Sure enough, I factor these as x minus 6 and x plus 1, right? Because I want two numbers that multiply to negative 6 and add to negative 5. So, of course, the bigger of the two should be negative equals 0. So I either get x equals 6 or x equals negative 1. Let's check. X equals 6. The left-hand side would be the square root of 3 times 6 plus 7. And the right, and that is the square root of 18 plus 7. That's 5. The right-hand side is x minus 1. Check. Good. So now I can put it like that. Check. x equals -1. Square root of 3 times -1 plus 7 equals square root of -3 plus 7 is 4 is 2. Right-hand side, so maybe we can write here left-hand side, right-hand side, left-hand side, right-hand side. Right-hand side is -1 minus 1 is -2. Oops, 2 doesn't equal 2. That's an erroneous answer, right? And you can see the right-hand side is negative, and that's a square root. You can never have a square root of negative, right? But -2 squared is 4. That's why it was introduced erroneously, and we know this is not an answer. And in an exam, you may lose points if you don't check. So be careful. You always have to do that just to catch up anything that was introduced as you trying to simplify the problem. Okay, let's take another example. This example, I have two roots. Don't leave them on the same side. Why? Because if you keep them, when you square the left-hand side, it's the square of the first, you get rid of this. Square root of the second, you get rid of that. But twice the first times the second will introduce a more complicated root. And you say, okay, so I can square again. Yeah, you can do that. But if I move it to the other side, you would say, but it's still the same thing. Yeah, but the square root usually is less complicated, less complex. So let's try to see what we can do. So I'm going to say, okay, I'm going to add root x plus 1 to both sides. So now I have square root of 3x plus 1 equals 2 plus square root of x plus 1. You say, oh, but you will have to square. Yeah, we know that. We have to square probably twice like we would have done if we left these, but I think it would be more complex to keep it like that. Alrighty, so when we square, of course, the square and the square root cancel each other. So the left-hand side is basically 3x plus 1. The right-hand side becomes the square of the first plus twice the first times the second plus the square of the second. And now we can simplify by moving everything to one side, all the non-radicals to one side, and keep the radical on the right-hand side. So the 4 root x plus 1 equals, I can write 3x plus 1, and then I'm going to subtract 4 from both sides, subtract x from both sides, and subtract 1 from both sides. So minus 4 minus x minus 1, the 1 and the 1 cancel. So I get this equals 2x minus 4, which I can simplify by dividing left and right by 2 if you want. So I can rewrite this as 2 root x plus 1 equals x minus 2. Then you have to square again. Notice we had 2 radicals, so we had to square twice anyway. And now, like we said, the square, the root would cancel, but before doing that, you have to realize it's 2 squares, so it's 4 times x plus 1 equals x squared minus 4x plus 4. This is 4x plus 4. Subtracting 4 from both sides, cancel them. Subtracting 4x from both sides would make the equation become x squared minus 8x equals 0. X, you factor it out, so you get x minus 8 equals 0. So either x equals 0 or x equals 8. Don't forget, we have to go back. Check. X equals 0. Left-hand side. If x equals 0, I get the square root of 1, which is 1. Right-hand side. Oh, I'm sorry. Square root of 1 minus the square root of 1, which is 0. Right? Because this, when x is 0, that's 1 minus 1. Right-hand side is 2. The original problem was square root of 3x plus 1 minus the square root of x plus 1 equals 2. I got 1 minus 1 equals 2. Erroneous. What about x equals 8? For x equals 8, left-hand side. Square root of 8 times 3 is 24, plus 1 is 25, minus 8 plus 1 is 9. So it's 5 minus 3 equals 2. Right-hand side, we already have it as 2, so it's correct. My own answer is 8. Okay, in this case, we had to square twice because we had 2 roots in the problem. Let's move to the third and last one we have. Trying not to make it long for you. Okay, x minus 2 to the 1/2 minus 28 minus twice x to the 1/4. Okay, so since we are like, we don't have any constant terms except the 0. And since we have 2 roots, we have to move 1 to the other side. So, oh my God. So we can add 28 minus 2x to the 1/4. 1/4. And then I'm going to square once. Notice 1/2 meaning square root, right? 1/4 is the 4th root. So now the left-hand side, when the 2 and the 1/2, you multiply them, you get 1. So the left-hand side is x minus 2. The right-hand side, 1/4 times 2 is 1/2. So now it's the square root. You can write it to the power of 1/2 or just square root of 28 minus 2x. So we square again. Okay, left-hand side is x squared minus 4x plus 4. Right-hand side is 28 minus twice x. So I'm going to subtract 28 from both sides, and I'm going to add twice x to both sides. 0. And the left-hand side, I hope I'm not going fast for you. X squared minus twice x minus 24 equals 0. You wanted 2 numbers that add up to 24. I'm sorry, they multiply to 24, and the difference is 2. So it must be 6 and 4 negative. So the 6 is negative and the 4 is positive. You can write it as x minus 6 times x plus 4, or x plus 4 times x minus 6. It doesn't matter. Okay, so either x equals 6 or x equals negative 4. For x equals 6, the left-hand side becomes x minus 2, which is 4, square root of 4 minus 28 minus 12 is 16. We can write 2 square roots or to the 1/4 power. This is 2 minus 2 equals 0. The fourth root of 16 is 2, right? The right-hand side is 0. So x equals 6 is fine. For x equals -4, left-hand side, I have x minus 2 is -6. Square root of -6 is imaginary. You stop and say erroneous. There is no reason to continue. Okay, you cannot have a square root. You can't have a real outcome of a square root of a -n, right? That would be root 6i. So I think that covers pretty much anything you will encounter in radical equations. If there is anything missing, or you need a specific problem, or something is unclear or wrong, I don't know. I think we checked everything, but there's always possibility for mistakes. So if you have any comments, please leave me a line in the comment section, and I'll get back to you as soon as I can. Thank you very much. Have a great day.